Okay, so let's look at some of the fundamentals involved in encryption. What we have, we typically define as standard text or plain text. This is typically defined in ASCII characters. So we would typically view them as letters, A, B, C and D, but they are interpreted by the computer in some form of byte format. So in this case, the letter A in ASCII is represented by 10000001, a B, C, and D, and so on. When we typically encrypt the binary stream. So the binary stream is then encrypted into a ciphertext. It is very difficult for humans to actually be able to view ones and zeros, so we typically view it in terms of either a hexadecimal format or in a base 64 format. For hex is a convenient way for viewing binary. In hex, we take 4 bits at a time and we convert that into a hex character. So in this case, 1001, we look up the binary table and we find it here. So the hex character for that is a 5, second one is an E, and so on. So hexadecimal is a convenient method to represent our bit stream, in that we can very quickly convert these values because we only have to remember 16 different characters. The other way that can be used is a standard way of representing binary in messages such as email messages, and that is base 64. With base 64, we take 6 bits at a time and we convert that into a character. So we can see here the first character is, the first 6-bit stream is 010111, and that is equivalent to a 1, 2, 4, 7, and a 16, which is 23. So 23 represents an X. So this is defined as base 64 format and is a useful way for actually sending binary information over standard text-based protocols. The other 2 operators that we'll see in encryption are fairly simple ones, and this is where we take bits together, line them up, and then we use the exclusive OR operator. With exclusive OR, a 1 and a 1 gives us a 0, and a 0 and a 0 gives us 0. A 1 and a 0, or a 0 and a 1, gives us a 1. So we can see in this case a 1 and a 1 gives us 0, 1 and a 0 gives us 1, 0, 0 gives us 1, 0, 1 gives us 1, and so on. The great advantage with exclusive OR is that we don't actually lose any information when we exclusive OR something with something else. Typically, we can inverse the operation by exclusive ORing it again with the same value. The other operation that we use is a shift left, rotate left, or rotate right. In this case, we have rotate left 2 spaces, so all the bits go 2 spaces to the left, and then the bits that come off the end go into the start. So we can have a rotate left, which goes that way, or a rotate right. Each time the bits come off the end and go on the other side, and that way no information is ever lost. Okay.